My name is Adam Moss. I'm a CHIP MPS student, as Erica has said. My internship report will be on Dynamedics Information Retrieval. So for my agenda today, the first point will be to intro to Dynamedics. The second will be information retrieval overview. The third will be Dynamedics search ecosystem. And the fourth will be looking at the project, my main project with my internship, the Dynamedics search functionality analysis. So Dynamedics is actually a combined solution. It seamlessly combines the clinical expertise and extensive curated disease content of EBSCO's Dynamed with the comprehensive depth and breadth of drug information from IBM's Micromedics. My internship was with EBSCO, and so our focus was on Dynamed. We looked at this combined solution. Micromedics has AI capabilities with Watson. And so that's a very interesting aspect that I was able to get familiar with as well. So Dynamedics intended users, these are really clinicians who are needing content and answers to clinical questions really quickly. So physicians, pharmacists, nurse practitioners, as well as other clinicians. So the first part was to see the Dynamedics business environment and how search functionality really, how that interplays with the business environment. And so I have here 4 different areas that are critical for businesses to survive. They look at regulatory fit, economic fit, market fit, and competitive fit. And search functionality really fits in with market fit and competitive fit. And so for market fit, one of the main goals of Dynamedics is to provide the most relevant content to the clinicians as effortlessly as possible. And so to minimize their clicks to get to their content. And so that was market fit. And for competitive fit, considering that Dynamedics is a clinical information product, if you improve the search functionality, that will inherently make the product more competitive. And so search functionality is a key performance indicator. And so what is a key performance indicator? KPIs, these are the key factors that enable or prevent company outcomes, such as increased profit from being achieved. KPIs provide immediate feedback on what is happening currently and provide early warnings of emerging results. And so therefore, evaluating the status of Dynamedics search functionality, it was critical to understanding how this will affect EBSCO's growth now and in the future. And so as a result of this important project to the company, I had to learn more about information retrieval and also how search functionality works in Dynamed, which will be my next transition points. And so what is information retrieval? It is the finding of materials, usually documents of an unstructured nature, such as text, that satisfies an information need from within large collections. And these large collections are usually stored on computers. And so digging a little bit deeper, I had to learn more about inverted indexes. And so inverted index, so for each term, such as cardiac, COVID, or hypertension, we have a list that records which documents the term occurs in. So for example, with cardiac, it occurs in the first document, the third document, the 5th document, and so on, that is stored within the computer. As you can see here, cardiac is very similar to hypertension. And so hypertension also occurs in the 1st and 3rd documents. And so each term in associated document IDs, these are conventionally called a posting. And so this list is called a postings list, and all the postings lists taken together are referred to as postings. And so the benefits of an inverted index is that you can avoid linearly scanning the text for these terms. So you increase your speed of your queries. And also statistics, you have statistical benefits. You can show the number of documents which each term contains, so the document frequency. And this is also used in rank retrieval models. Cons of this model include the storage of this dictionary. And so the data structure, there has to be a data structure, the vocabulary, and then also the postings list. And so next we'll look at ad hoc retrieval task terms. And so ad hoc, these are really one-off searches that clinicians may put into the Dynamed system, such as COVID or cardiac, to get more information. And so you really look at three different aspects. On the left here, I have information need. And so the information need is the topic about which the user desires to learn more about or to know more. On the right-hand side is the query. This is what the user conveys to the computer in an attempt to communicate the information need. And so the queries can range. So if the topic is COVID, the query could be COVID, it could be COVID-19, it could be coronavirus. And so the query really may differ by user. And so what you look for is relevance. So this is documenting that the user perceives the containing information from the computer has value with respect to their information need. And so it's really the middle ground between the information need and the query. And so you also have to assess the effectiveness of these information retrieval systems. There's really two components or two aspects that you use or measures to assess effectiveness. The first is precision. So what fraction of the return results are relevant to the information need, as mentioned in the previous slide? Recall, on the other hand, is the fraction of the relevant documents in the collection that were returned by the system. And so recall differs because the search term may have different, the user may have different needs, and so their perception of relevance may differ. But recall is that the computer pulls as many documents as possible that has that term. And so the more documents it pulls that contains the query, the recall is increased. So the selection is wider. All right, so next I will talk about the search ecosystem. And so this is really getting under the hood of Dynamed in the search. And so this is the code and the infrastructure where they come together to create the search experience for the users. And so the first part is the search prep. So the writers, they have content, the content is transformed, and then there occurs semantic enrichment. And so semantic enrichment is the process where all of the content that the writers have is compared against the knowledge graph. And the knowledge graph, which I will explain in the next slide, contains concepts and relationships. And so it really digests all of the content and puts it into this nice graph or this nice map where you have terms that are connected. And so that enhances the semantic meaning of the terminology of the document. And then also indexing, as we have discussed previously. On the right-hand side, you have search runtime. And so the medical search platform and query intelligence, which I will discuss later as well. Both of these are in the search runtime, which basically these two functionalities help improve the search experience for users. And then there's two types of feedback. There's user feedback and expert feedback. So expert feedback, you really rely on EBSCO's staff to look at some of the results that the computer gives and to give it a grade and to say, well, this topic should occur before that topic. And so to really rank them, and these are called judgment lists. There's also graph curation, and there's also surveys and experiments that are done. And user feedback, you can look at users to see how many times, this is more web analytics. And so you can look to see how many times a user clicks on a topic, and that will be your click-through rate. And I will also discuss that as well, or your conversion rates, and also A/B testing with users. And so all of these things come together for the search ecosystem. It really is a complicated, complex area, but as you can see, it provides business value for EBSCO. And so that's why I was very interested in the project. And so here I'll discuss the medical knowledge graph. And so you can see terms such as Zoloft or selective serotonin, which the user may type in the query. These are connected to concepts, which are in orange. And you have RX norm vocabulary, which it connects to. And so then within each orange circle, you have relationships, which are the arrows to show how these are all connected. And so this really helps streamline the search experience from the back end, from that users do not see this, but from the back end on how to provide the content that users are searching for. And so query intelligence. And so this is within search runtime. And so in this example, you have semantic recommendation, which points to breast cancer. And so breast cancer is 2 words, but it's one concept. And so semantically, that is an example of semantic enrichment. It knows that breast cancer is a term or a concept. And so that's part of the graph. And then next you have click-through recommendations. And so you can see breast cancer in women as a topic by Dynamed staff that has a weight of 0.55 out of 1, which is the highest ratio. And so by basing it on click-through recommendations, that will be your first term that appears in Dynamed, because you're basing it off of click-through recommendations, which are provided by the user. And so after going all of the how all of the search functionality works, I will now discuss the search feedback project, which was my main project during my time at EBSCO. And so for background, improving search, as I've already discussed, is a continuous quality improvement project for EBSCO clinical decisions. Frontline users, we ask frontline users to complete scripted and free form searches in both products, with the goal to gather and analyze feedback from frontline users to understand their current state search performance, make recommendations, and to improve results so that the frontline users can get these answers as quickly as possible to their clinical questions. And so how was this structured? And so it was using a standardized structured data collection form. Participants were asked to conduct 50 prescriptive and 10 free form searches. And so the 50 prescriptive means that users entered pre-specified search terms. And so there were 50 pre-specified search terms. These spanned across many different categories so that EBSCO, we could really get a good understanding of how the different areas of content perform. The different areas of content include disease or drug acronyms, short form searches, long form searches, as well as study name acronyms. And these search terms were proposed by Dynamed staff and also search logs that were reviewed. And so for each application, participants were asked to evaluate the following: evaluate the list of search results, rank Dynamed as well as the competitor on a scale of 1 to 5 on how well the search results were, state which result they preferred better, Dynamed or the competitor, and why, and then also comment on how search could be improved for Dynamed. And so here you'll see DMX, and that's just referring to Dynamedics. And so I just want to make that clear for the rest of the presentation. In addition to the 50 prescriptive searches, the participants had to complete 10 free form searches. And so they had to think of a patient or clinical question that they needed to answer. And so free form just means that they entered in the question themselves. So it was not prescripted. They had freedom to search for any topic that they would want to search for, any clinical question. And they entered those search terms to let us know what they searched for. And they also evaluated the search results using the same format in both applications. And they did 10 of those. So all in all, there were 11 physicians that were recruited. 8 completed the survey. There was a mix of family medicine practice settings as well as academic medical center attendings and residents, and 1 fellow. And so we had a really great mix of physicians that completed the survey. For Dynamedics experience, I would say for the most part, most physicians had much more experience using the competitor product compared to Dynamedics. But there were some physicians that did have experience with Dynamedics. And so now I'll get into the pre-specified search results. And so when asked directly, the participants preferred the market competitor product compared to Dynamedics for the prescriptive searches. For 42% the competitor, 30% for Dynamedics, and 28% tie. And when using the mean of all of the searches for prescriptive searches, 5 being great, 1 being poor, you can see that the 2 products actually fared comparably. Dynamedics had an overall score of 3.7 and the competitor product had a score of 3.9. And so this is a subgroup analysis looking at the acronyms. And so you could see there were non-disease acronyms, COPD, DVT, TORCH were examples, and 3 drug acronyms. And Dynamedics and the competitor performed basically equally on the acronyms, 43% for the competitor, 42% for Dynamedics, and 15% tie. And this just gives an example of even further breakdown of each term that was searched for the acronyms. And so you can see Dynamedics did really good for search terms such as COPD, as well as AFib And the competitor product did really good for acronyms such as PALS, as well as SIADH. And this looks at drug acronyms. And so you can see the Dynamedics did the best for BCP, which is birth control pill. And the competitor product did really well for K2, but performed poorly for FinFin. And so now this is looking at study name acronyms. In almost 60% of the cases, search results for study name acronyms were ranked the same in both Dynamedics and the competitor. Although in the majority of the remaining cases, participants preferred the competitor. And so next I'll go to, these are the study name acronyms. And there were some conflicting terminology used for some of these study name acronyms, such as CAST. CAST is the name of a study name acronym, but that could be misinterpreted by both applications as a ARM cast or other types of cast, as well as ACE. ACE is another study name acronym that could be misinterpreted as the ACE inhibitor, which is a drug. And so you can see that both of these study name acronyms perform poorly for both systems. And you can see the results for the other study name acronyms here. And so now I'll get into the short form searches, in which Dynamedics outperformed the competitor for the short form searches. These include, examples include hypertension, pancreatitis. These are really one word searches, and as well as 3 drug, augmentin, Wellbutrin, and clindamycin. And so Dynamedics did really well, 42% preference compared to 35% for the competitor and 23% tie. And then this gives the further breakdown. You can see that, for example, influenza, Dynamedics had a perfect score of 5, which is really phenomenal. And so the competitor product did really well for shingles and also psoriasis. And so hopefully you can see these give examples of where Dynamedics can improve their content. And these are a short form for search for the drugs. And Dynamedics outperformed the competitor product on all of the drug acronyms, and so, or short forms for the drugs. And so also Dynamedics does include IBM's product Micromedics. And so that's part of the benefit in that solution is being shown here. And so now look at the long form searches. These are multi-word searches, and the competitor outperformed Dynamedics for these type of searches. And there were 14 types of these searches. And so an example would be fungal infections and knee replacement, as well as Cushing syndrome diagnostic approach. The competitor had a preference of 53% compared to Dynamedics of 25% and a 22% tie. And so for the long form searches, these give a really breakdown of each of the long form searches. As well, you can see right here in the middle, fungal infections and knee replacement, Dynamedics had a score of 1. And so obviously that raises a flag to say, let's update that content to make sure that we improve that area. Areas that Dynamedics did outperform the competitor would be in the first one, differential diagnosis of abdominal pain, as well as bisphosphonates to treat osteoporosis. And so we'll look at a long form search example. This is adhesive capsulitis shoulder. So the pattern here is a condition. It has 3 terms, but it's one condition, and it's fairly common. It's also known as frozen shoulder. When you break down the statistics, Dynamedics had a mean of 4 and UpToDate had a mean of 4.7. The ranges was 3 to 5 for Dynamedics, and the range for UpToDate for the competitor was 4 to 5. And the mode was 4, and the competitor's mode was 5. So the most relevant topics surfaced first in Dynamedics. The topics that followed were relevant and some irrelevant topics near the end. And so you can see here, I'll just have what this actually looks like in the system. The first topic when you type in this search is adhesive capsulitis of shoulder, which is what you want. And then later you get rotation cuff tear, management of rotator cuff impingement. So these are topics that may be part of a differential diagnosis of shoulder pain. But one of the feedback from the users was that there's also irrelevant topics towards the end. And so you can see here at the bottom, these don't really relate to the topic. And so that may be an area of improvement as well. And so for the freeform search results, so when asked directly, the participants preferred the competitor compared to Dynamedics for freeform searches. And so the competitor was preferred 49% compared to Dynamedics 16% and a 35% tie. And when looking at the scale, Dynamedics had an overall score of 3.9 and the competitor did 4.4. And so that's a really great strength of the competitor product. And so breaking it down, the users, when they had free form, they only used acronyms 5 times. They used short form searches only 6 times, and they used long form searches 69 times. So it was overwhelming. And Dynamedics did outperform the competitor for the acronyms, and the short form searches competitor did better than Dynamedics. And then for the long form searches, the competitor outperformed Dynamedics as well. And so this just gives a graph, a pie chart of showing how users tend to use the long form queries for most of their searches, which are, they usually have 2 or more words, often 2 or more concepts. You can see examples there. They're mostly in point form. They're not in sentence form. And they often have 3 or more terms, which really limits the Dynamed output. And these are real examples from the data collection log of the freeform searches. On the left is from one physician, and on the right is from a second physician. The regular font indicates the search terms that were entered, and the italicized font indicates the clinical question or scenario that they were looking to get the answer to. And so just to do an additional analysis, I did look at the search log that Dynamed has for their system and compared it to their freeform searches to see the frequency of those terms in the system. And so for new searches, which had 0 prior entries, such as an example would be ketamine refractory pain, the new searches, there were 24 of those. And so then, and for 1 to 10 prior searches, such as PTH CKD, there were 20. For 11 to 100 searches, such as drug-induced liver injury, there were 15. For 101 to 1,000 prior searches, such as insomnia treatment, there were 12. And for 1,000 plus prior searches, such as hyponatremia, there were only 1. And so the users were really using new searches or unique searches into the system when they were doing their freeform searches. And I think that gives really good insight into how users are searching for terms. And so the next step would be to analyze how the Dynamedics product compares to the competitor for those different types of searches. And so as you can see for new searches and the 1 to 10 searches, the competitor product does really well. 4.1 for new searches, 4.7 for 1 to 10 searches. And Dynamedics, on the other hand, improves as the search frequency increases. And so for 100, from 11 to 100 searches, it goes 4.3. 101 to 1,000, there's 4.8, and for 1,000 plus, there were 5. And so the trend really is, as Dynamed sees those searches more frequently, they improve, the user experience increases. And so this is a SWOT analysis for the prescriptive long form searches. And so a strength would be that the top result matches the search as shown in the adhesive capsulitis shoulder. There are a great range of results and also all relevant results. Weaknesses would be that you may only have one exact result. And so sometimes related topics, these are important to users we found during the study because they may have an idea of what they're looking at, but it's just like browsing. If you see another topic that interests you, you may want to explore that topic as well. Also, another weakness would be yielding an unrelated result and also unrelated entries later in the list. Opportunities to improve include proximity weighing. And so a document that is preferred to the extent that the query terms appear close to each other in the text. And so proximity weighing would be, an example would be cardiovascular prevention. And so if you search cardiovascular prevention, instead of the document pooling cardiovascular separately from prevention, you're only pooling documents that have cardiovascular next to prevention. And so the proximity of the terms, having a greater emphasis on how those topics are returned. Threats would be brief excerpts in the competitor product explaining why the results appeared. And so that was what the physicians did, like the brief excerpts, because that way they can save time from clicking on the topic. They can just read to see if it matches their search, their query. And then also narrow topics. And so some of the narrow topics that are very specific, Dynamedics may not have a lot of content to yield those more relevant search results. And so for conclusions, we established a current state baseline performance for Dynamedics search, as well as in comparison to the main market competitor. Overall, the users preferred the competitor for the prescriptive searches. For the subgroup analyses, Dynamedics and competitor approximately performed equally on the acronyms. Dynamedics slightly outperformed the competitor on the short form searches, and the competitor outperformed Dynamedics on the long form searches. And so the majority of the free form searches were long form queries. And so that lets us know that needs to be an area of focus. And the two applications were ranked equally for study name acronyms in approximately 60% of the cases, although in the remaining cases, participants preferred the competitor. And so for the next steps, the goal will be to focus on the long form searches. There's opportunities to improve search query intelligence. We missed opportunities to surface topics that users may see as relevant to their initial search term. We can also adjust the ranking, such as through click-through ranking or through the judgment list provided by the experts. We can also minimize or remove irrelevant topics at the bottom that users may get frustrated with because they don't see how it relates to their query. We also can evaluate and close content gaps as needed by the medical writers. We can also revisit highlighting search terms in Dynamedics, which will allow users to see how their term appears in the content easier as opposed to having to click on the term. And then also consider how to handle new searches, which I was really interested in. These are the searches that have 0 prior search log entries, or maybe even 1 to 10, where they're not seen by the system a lot. How can we handle those better to improve user satisfaction? And these are my references. Thank you. And I'll take any questions.